Hello friends, welcome to session 10 on projection of lines. We'll continue with the main problems. See here, there is a problem here which is very important from the examination point of view and all that, considered to be difficult. And if you understand, again it will be very easy. See here, there is a problem, ND of the line AB is in HP. Okay, anyway, ND of the line AB is in HP means A dash should be on XY line. With end B touching VP, that means B should be on XY line. Did you follow? B touching VP means in the top view of AB, no? B should be on XY line. End A of the line is in AB means A dash should be on XY line. Anyway, I'll come to this. The line is inclined at 45 degrees to HP and 30 degrees to VP and line measures 100 mm. The three parameters are here. The line is inclined at 45 degrees to HP, 30 degrees to VP and the line measures 100 mm. You just adjust for this these things in the front and top views. That's all. Because the three parameters are already given. The line is inclined at 45 degrees to HP, 30 degrees to VP and the line measures 100 mm. Okay. And draw projections of this line and they determine apparent inclination with respect to HP VP. The only thing what they are given is draw also the left view of the line on RPP and find the shortest distance of the line from the intersection of HP VP and all that they have said. See here, look here, there is a problem here where one end of the line is touching HP and other end of the line is touching VP. Okay, one end is touching HP, other end of the line is touching VP. Okay, in that case, you can find the shortest distance of this line from the intersection of HP VP. Okay, anyway, you will know shortly. Okay, now XY line you write, VP HP you write. Since A is on HP, A dash you take it on XY line. Draw a line at 45 degrees because they are given a line is inclined at 45 degrees to HP. Draw a line at 45 degrees to HP and cut 100 mm here. Get the locus, make the locus ready. Okay. Okay. Now you see here, there is, the line is inclined at 30 degrees to VP. Okay. And measures 100 mm only. Okay. The true length is 100. But the interesting fact here is, they say when you draw a line at 30 degree, the end B should be on XY line. Okay, that is why I made a small construction here. You do this construction separately because end B should be on VP. End A is on HP. End B should be on VP. That is why put B here, A here, capitals. It's just an auxiliary construction, that's all. B and A you do, draw an inclination at 30 degrees and cut 100 and come here. Then you get the distance of NDA in front of VP. Okay. Now, why I have done this is, now with A as center, if you draw a line at 30 degree and cut 100, automatically your B will be, that locus will be on XY line only. That's the idea. That means, finally, I want B should be on XY line because the end B is touching VP. That is why I have done this construction. BA 30 degree and you do this and get the projector from here so that since this is done already, now if you draw a line at 30 degree, here 30 degrees to VP and cut 100, automatically it will be cutting on XY line only. That is the idea. Okay. Anyway, once you know this construction, why it has been done and all that, okay, I'll repeat. This construction has been done only to ensure the point A. Once you get A, if you draw a line at 30 degrees to VP and cut 100, automatically it will cut on the locus. Okay, it won't cut anywhere. 30 degree and if you draw a line at 30 degree and cut 100, automatically it will be an XY line because the same thing you are repeating here. Okay, now the true length is here. Corresponding other view parallel to XY line. You draw this parallel to XY line. AB1 you call it, A dash B1 dash true length. Corresponding other view parallel to XY line, which I have been telling you again and again. Once true length is found, immediately draw the corresponding other view parallel to XY line, which you can rotate till it cuts the end projector or locus. But here they have already given end B is touching VP, correct? No, end B is touching VP. End B is touching VP means the locus is on the XY line only. That is why A as center, AB1 as radius, draw an arc to cut the locus only. Locus is XY line only because end B is touching VP. Okay, that is why end A as center, AB1 as radius, draw an arc till it cuts the locus because B is on VP. Please remember B is on VP and A is on HP. Okay, now you see here, draw this, you get the top view of the line. Okay, top view of the line. Okay, once you get the top view, take the projector up, you get the front view of the line. Okay, now you see here, the end A of the line is on HP, correct? No, some distance in front of VP. End B is on VP, some distance above HP, correct? No, you please understand correctly. End A is on HP, some distance in front of VP. End B is on VP, some distance above HP. Now, once you have this, okay, end A is on HP, end B is on VP means you have to find the shortest distance. You will know shortly how exactly to find the shortest distance. Now, here you know this is actually alpha, this is actually beta and all that. This is anyway 30 degree, theta is given already. You don't have to worry. Now, draw the side view here. This is alpha, this is beta. Now, you draw this side view. X1, Y1, VP, HP, this is RPP. Now, you see, once you draw the 45 degree line side view, on this, you draw this. On this, you draw. This is A double dash. Okay. On this, this is, can you see? This is B double dash. Okay. This is B. A is here. A from here. A from here, you get A double dash. B from here, you get B double dash. This is how this line is seen in the side view. When you look from left view, no? When you look from the left view, please understand, when you look from the left, this is how the line is seen. With end A on HP, end B on VP. That is why A double dash on XY line, B double dash on XY line. This is a very good problem from the examination point of view. Consider it to be difficult. Now if you understand, it will be easy. Now you see here, A double dash on XY line, B double dash on VP. Okay. A double dash on XY line means it is A is on HP. B double dash on X1, Y1 line means B is on VP. Now to find the shortest distance from the intersection of HPVP, the intersection of HPVP is origin. From that, you draw a perpendicular to this. You draw a perpendicular to this, automatically that this is the shortest distance of this line, that is this line, from the intersection of HPVP. That is 41 mm. Everyone should get the same distance, same answer, 41 mm. This is a very good problem from the examination point of view. Do it carefully. The important thing what you can never forget here is end A is on HP. Okay. Okay. Then I have drawn this construction. The line is inclined at 30 degrees to VP. 30 degrees to VP I have drawn and cut 100. So that when you get this point A, no, in front of VP, if you draw a line at 30 degree and cut 100, automatically it will be on this locus only, that is XY line only. That is why I draw. Okay. Once you draw 100, draw the corresponding top view parallel to XY line, which you can rotate till it cuts the locus. Locus is XY line only because end B is touching VP. Once you get AB, take the projector up, you get A dash B dash only. Draw the side view. Okay, draw the side view. The side view will look like this. And from the intersection of HVVP from here, draw a line perpendicular to this line. That will be the shortest distance. You measure it. That will be 41 mm. This is a very good problem. This is actually the 15th problem from BTU textbook. Okay. Now is here. So this is a very good problem again. I'll try to cover as much as possible. The midpoint of a line. So far, we are doing problems with one end fixed, other end moving. One point is fixed. One that is for the line AB. End A is a fixed point. End B is a moving point. But here, the midpoint of a line means midpoint is fixed, so that both A and B are moving points. The line is inclined at 30 degrees to HP, 45 degrees to VP, and the line measures 100 mm and all that. Whatever is that, just see here. So far, I'm just giving you a clue how exactly we are doing till now. Here, the line is PQ, no? Okay, line is PQ. the corresponding front view is this, corresponding top view is this, and this is the front view, top view. These things I've told you so many number of times, you know. The line is PQ. Now it is 30 degrees to HP parallel to VP. How you are rotating with respect to VP? End P fixed, I used to move Q either this way nearer to VP or nearer to observer, so that it will have some inclination to VP also with a constant inclination of HP. HP inclination I am not changing, 30 degrees will remain same, but Q I used to move this way or move this way, so that some inclination to VP is also obtained, so that the problem becomes a line inclined at 30 degrees to HP and some inclination to VP also. This is one end fixed, other end is open for rotation. But in these problems, what I'm doing, instead of fixing at end P, I'll fix at the midpoint here. Can you understand? Between P and Q, midpoint. When you fix at the midpoint distance above HP in front of VP is given. That should not change. When you rotate the line, Q, if it goes this way, P will come this way. That means you will have locus here as well as locus here. Can you understand this, all of you? Please follow. When this is this, okay, when midpoint problem is given, this is fixed at, this midpoint is M, let us say here, M is here. With M as the pivot point, okay, the line is inclined at 30 degrees to HP, let us say. And if I want to give some inclination to VP, I'll move Q. I'll be rotating with respect to M only. Okay, midpoint. Midpoint cannot change. Midpoint distance above HP in front of VP, that should not change. When you move Q nearer to VP, P will come nearer to observer. In that way, the problem becomes double locus problems. Here afterwards, these problems, the midpoint problems and all that, we call it as double loci problems. Okay, I'll repeat. In these problems what we have done till now, end P was fixed. That means the end P is how much? 40 mm in front of VP, 20 mm above HP. This is fixed. Okay, this was fixed, and whatever may be the thing, 40 mm above HP, 20 mm in front of VP, whatever is that, projections won't change. 40 even if it is 50, it does not change. 20 if it becomes 30 also, it does not change. Okay, now with this 40 and 20, the point P is fixed. At a distance of 40 in front of VP, 20 above HP, the point P is fixed. Now I was moving Q only. P is fixed, Q I am moving with a constant inclination of 30 degrees to HP only. When Q is moved this way, it is nearer to VP. This way is nearer to the observer. Okay, nearer to the observer. But P is always a fixed point. 20 above HP, 40 mm in front of VP cannot change. It is only Q which is moving. That means there is only single locus in the front view or single locus in the top view for these problems. Okay. And while rotating this way or this way, that is rotating point is, moving point is Q, fixed point is P here, moving point Q or rotating point Q, okay, when it is moved this way or this way, inclination to HP is constant. In the same way, in these midpoint problems, instead of fixing P, I'll fix it at M, which is the midpoint. When midpoint distance above HP in front of VP will not change. Whatever is the distance, you fix it. If they don't give, you assume the distance. Once you assume the distance, that should not change. It will be constant. That means I'm pivoting at M and rotating the line. Okay, let us say 30 degrees to HP. And if I want to give inclination to VP, I'll move Q this way, so that Q, when it goes nearer to VP, P comes nearer to the observer. Or P comes nearer to the observer, Q goes to VP. If Q comes nearer to the observer, P goes nearer to VP. In that way, here these are all the problems related to midpoint problems where M is the midpoint between P and Q. In the next session, we will be doing on midpoint problems only. Now we come to the end of session 10. Thank you friends. Thank you viewers for watching. Thank you.